Good day to everyone. We are from Group 2. Our group consists of 4 members. Now, we are going to present our integrated project with the title The Productions of Rhamnolipid from Bacteria. Rhamnolipid is a type of surfactant which act as wetting agents to lower the surface tensions of a liquid and allow for increased spreadability such as detergent. Rhamnolipid is produced through Pseudomonas aeruginosa fermentation.
Usage and applications of rhamnolipids. Firstly, bioremediations. Rhamnolipids are used to remove heavy metal and petroleum pollutants from contaminated sites. Secondly, agriculture. Rhamnolipids play an important role in the efficiency of new biopesticides. Thirdly, food industry. Rhamnolipid can improve the stability of dough, texture, volume, and conservation of starch-containing products. Next, cosmetic and pharmacy industries. Used in several healthcare product formulations such as toothpaste, deodorants, and contact lens solution. Lastly, detergent formulations used as biosurfactant.
Next is economic analysis of rhamnolipid. The figure shows global demand and supply graph of rhamnolipid from the year 2019 to 2026. Rhamnolipid market is expected to grow with a CAGR of 5% from the year 2020 to 2025. Next, market price of rhamnolipid. Global rhamnolipid market is predicted to be at 4.2 billion USD in the year 2017 and to reach 5.52 billion USD by the year 2022 with a CAGR of 5.6%. Next, for plant capacity, there is deficiency of 250.6 kilotons of rhamnolipid globally in 2026. We decided to produce 5% of the global deficiency, which is 12.53 kilotons of rhamnolipid. Our plant will operate for 8,520 hours and can produce 1,470 kg per hour of rhamnolipid.
The 4 main processes in the productions of rhamnolipid by Pseudomonas aeruginosa are seed preparation, fermentation of carbon source, which is the glycerol, and the nitrogen source, sodium nitrate, in the presence of oxygen gas to produce rhamnolipid, followed by the extractions of rhamnolipid through acid precipitations and the purifications of rhamnolipid by petroleum ether. This is the process flow diagram of the productions of rhamnolipid by Pseudomonas aeruginosa. In the process flow diagram, we include stream table with temperature, pressure, phases, as well as the mass flow rate of the raw material, product, and byproduct for each stream.
For the safety issues, there are certain materials that should be taken precaution with as it can be harmful. The first one is sodium nitrate, which can cause irritation to the eyes and skin when in contact. And the second one is phosphoric acid that can cause severe skin burn and eyes damage. Therefore, it is important to store and handle them in the right way. Sodium nitrate is stored in a cool, dry, airtight container and well-ventilated location away from flammable items and incompatible chemicals. And same goes to phosphoric acid. It is stored in a cool, dry, airtight container and well-ventilated location at temperature that is not close to freezing point, away from oxidizing agent and direct sunlight. Also, they should be used in chemical farm hoods and well-ventilated area, and make sure to wash hand after handling.
Environmental issues. The treatment and disposal for biomass is heat approximately 225 until 275 degrees Celsius by using thermal decomposition process. At this temperature, a portion of the compounds that are volatile also evaporated and can be used as a fuel to power the process. Next, fermentation broth. If the solution has pH 5 or lower, it must be managed as dangerous waste. Collect solution in a compatible container with a vented lid designer for acid and base storage. Lastly, petroleum ether. Burn in chemical furnace equipped with an afterburner and scrubber, but use caution when lighting because the material is extremely flammable.
Next is the mass balance of the rhamnolipid. In the fermenter, the mass balance is balanced at both sides with a value of 2877.491 kg per hour. Then, the overall mass balance is also balanced at both input and output with a value of 6377.492 kg per hour.
Next is the energy balance at the fermentation tank. The enthalpy of reaction that we calculated using the components heat of formation is equal to negative 989.89 kJ per mole, and with the value of R equal to 24.917 kmol per hour, we obtain the value of heat transfer Q equal to 6833.35 kJ per second. As the value is negative, we know that heat is released and the reaction is exothermic.
Next, for the thermodynamic task, the value of equilibrium constant calculated is 1.1113. Then, assuming all components are in liquid phase and an ideal solution, the extent of reaction calculated is 10.215 using the equation shown. On the next part, there is percentage error between the composition of biochemical equilibria and composition based on material balance, which ranges from 5 to 12%. This shows that the material balance calculations are more accurate because no assumption is made.
Above show the taxonomy classification of Pseudomonas aeruginosa. In order to select the best producer bacteria cell for the productions of rhamnolipid, we have chosen to compare Pseudomonas aeruginosa, Burkholderia thailandensis, Pseudomonas chlororhynchus in terms of optimum temperature, optimum pH, pathogenicity, and the conversion yield of rhamnolipid. We decide to choose Pseudomonas aeruginosa as the producer bacteria cell of rhamnolipid based on comparison made.
For the fluid mechanic parts, we choose to analyze the pump P103 between the mixing tank M102 and the centrifuge C101. The pipe that we choose to use is the commercial steel Schedule 40 with the 4-inch nominal diameter. As the Reynolds number obtained is more than 4,000, the flow is turbulent, and the total friction loss calculated is 0.2989 joule per kg. And from the mechanical energy balance, we obtain that the work done by the fluid is equal to negative 62.34 joule per kg. The pump that we choose to use is the centrifugal pump, and its suction head calculated is equal to 139.788 meters square per second square. Meanwhile, the discharge head calculated is equal to 201.962 meters square per second square. The net positive suction head of the pump is 9.847 meter with the pump efficiency of 55.87%, and the pump work done is equal to 111.58 joule per kg, and its power is equal to 138.545 kilowatts. From the pump performance curve graph, we can observe that as the pump efficiency increase, head loss decrease and net positive suction head increase.
The conclusion is rhamnolipid produced from fermentation of Pseudomonas aeruginosa and glycerol. Pseudomonas aeruginosa YM4 and glycerol chosen to get high yield, while our plant capacity for 355 days is 1,470 kg per hour. The upstream process is seed preparation. The growth of Pseudomonas aeruginosa is cultivated for 12 hours at 200 rpm, pH 7.5 until 7 degrees Celsius. Next, fermentation. While the downstream process are extraction and purification. The waste product for this production are carbon dioxide, petroleum ether, water, fermentation broth, and cell biomass. Since heat of reaction less than 0, fermentation process is an exothermic reaction. Total friction loss in pipe is 0.2989 joule per kilogram, while work done by fluid is negative 62.34 joule per kilogram. Net positive suction head of pump is 9.847 meter and pump power is 138.545 kilowatt. Lastly, the efficiency is 55.87%. That's all from us. Thank you.